Okay, let's look at the homework questions on the back of your sheet, another force review sheet to get you ready for the test. Question number 1, it says it's a 40 kilogram box being pushed across a level surface with the force parallel to the floor, tells us the coefficient of friction, tells us the acceleration in the x direction, and it wants this force. So we're going to start where we always start, and we're going to do some of the forces in the y direction. And of course, it's not moving in the y direction, and there are only two forces, Fn going up, Fg going down, so it's negative. So Fn is equal to Fg is equal to mg. So if you want it, you could find this value. It's 40 kilograms times 9.81 meters per second squared. And so you get 392.4 newtons, I believe, for your Fn. Now you go to the y direction, and you do some of the forces in the x direction, and you do some of the forces in the x direction equals max, and our forces in the x direction are F and friction. F is going in the positive direction, friction in the negative direction, and that's equal to max. And the question wants us to solve for F. So we can take our friction over. So it'll be max minus friction, which is really mu Fn. And so F is equal to m, which was 40 kilograms, A, which was 3 meters per second squared, minus mu, which was 0.25, times that 392.4 newtons. And when you type this in your calculator, assuming that I did not screw up on the sheet, you should get 218.10 newtons for number 1. Okay? Number 2. Number 2 is our good friend the curling stone. And it says the curling stone is thrown forward with an initial velocity. It travels for 49 meters, so that's delta D, before coming to rest. That's VF. And it wants to know what's the coefficient of friction. Friction's going to be acting back this way. And once you've released the stone, there's no forward force. Okay, so we're going to do some of the forces in the x direction to get the coefficient. But before we can do that, we need to have our A. So we can find our A going back to kinematics. You should hopefully remember that Vf squared is equal to Vi squared plus 2A delta D, and rearrange for A. So Vf squared minus Vi squared over 2 delta D. So A is equal to, Vf just goes to 0, so negative bracket 14 meters per second, that gets squared, and on the bottom 2 times 49 meters. Okay, so punch this will be your AX, so punch it in your calculator. 14 squared is just 196 divided by 98, and that should give you a wonderful acceleration of negative 2 meters per second squared. Negative because it's slowing down. Okay, so once we have that, then if you want it, you do the sum of the forces in the y. But at this point, hopefully you realize what it's going to equal when there's only 2 and it's not moving. It'll be Fn minus Fg is equal to 0. So Fn will equal Fg will equal mg. Problem is, I didn't tell you the mass of the stone, so you can't get a number here. You're going to have to carry it along. So sum of the forces in the x equals max, and when we go back and look at our picture, there's only one in the x, it's friction, and it's acting negative. So FFR is equal to max. And FFR is really just mu Fn. And the negative's there because it's opposing motion. So negative mu Fn equals max. And we know Fn right here is mg. So negative mu mg equals max. Solving for mu, so divide both sides by negative mg. And the m's are going to cancel. So you're just left with negative ax over g. So now fill your values in. Negative 2 meters per second squared divided by 9.81 meters per second squared. And you should get a mu of 0.20387, etc. Okay, so that's number 2. Number 3 is pulling upward at an angle. Gives you the acceleration, wants you to find the coefficient of friction. If first we do